In nature, being invisible seems like the perfect survival strategy when you're small and edible. A frog that blends into leaves, bark, or mud has a much better chance of avoiding hungry eyes. The rainforest is full of predators with excellent vision, so staying hidden should be the only sensible move. And yet dozens of poisonous frog species evolved to be the brightest creatures in the forest, flashing colors that are impossible to miss. If camouflage is so obviously the right answer, why did these frogs go the other way? What made being seen safer than being unseen? To a hungry bird or snake, a bright neon blue or glowing yellow frog looks like a billboard advertising a free meal. In the wild, flashing these loud colors usually gets you eaten immediately because it breaks the most basic rule of survival: don't stand out. But these frogs use their colors as a direct warning signal to advertise their toxic chemistry. Scientists call this warning strategy aposematism, where an animal uses bright visuals to tell the world that it's dangerous to eat. Imagine a young, inexperienced bird spotting a bright yellow frog for the first time. The bird flies down, snaps up the frog, and immediately experiences a horrible, bitter, burning sensation in its mouth. It drops the frog, choking and spitting as the toxins kick in. That single terrible meal creates a strong memory that lasts for the rest of the bird's life. From that moment on, the bird avoids anything that shares those bright, warning patterns. The poison these frogs carry is no joke. A single golden poison frog has enough toxin to kill 10 full-grown humans, or 20,000 mice. The main chemical they use blocks nerve signals, which quickly stops the victim's muscles and heart from working. So if a predator ignores that bright yellow warning, it doesn't just get a bad taste, it faces total paralysis. But here's the twist. These frogs don't actually make their own poison from birth. Their toxicity comes entirely from what they eat. They hunt down tiny, toxic ants, mites, and beetles, and absorb the chemicals without getting hurt. If you take a wild poison frog and raise it in a clean tank with only normal fruit flies, it gradually becomes completely harmless. It ends up just like a regular garden frog, because it lost access to its toxic food source. This survival strategy comes with a heavy price tag. A bright red frog can't hide from predators, which means predators spot it far more often than its green, camouflaged neighbors. In areas where predators haven't learned the lesson yet, they attack these colorful frogs on sight. But once the local birds and reptiles learn to associate the bright pattern with pain, the rate of attacks drops dramatically. The frogs trade the safety of camouflage for a different kind of shield, one that relies on the memories of their enemies. But this system isn't perfect. Some harmless frogs cheat by copying the looks of toxic ones. In Ecuador, a frog called the Paro rocket frog looks almost identical to a poisonous neighbor. Predators that have learned to avoid the toxic frog will also avoid the harmless copy, even though it has no poison. This trick works because the predators can't tell the difference. It shows how a warning signal can become a shared shield, protecting even animals that are completely harmless. Other frogs do the opposite, possessing real toxins but choosing to remain brown and camouflaged, relying on stealth rather than warning signs. Some poison frogs are not bright at all, instead wearing shades of brown and gray to blend with fallen leaves. These species often carry weaker toxins or live in areas with different predators. They show that warning colors are not the only way to survive with chemical weapons. If a frog is too slow to escape, blending in is still a very reliable backup plan. Some species even combine both strategies to get the best of both worlds. They wear dull, camouflaged coats on their backs to hide from distant eyes while keeping bright patches of red or yellow hidden on their thighs. If a predator gets too close and startles them, they jump, exposing a sudden flash of bright color. This sudden burst of neon startles the predator for a fraction of a second, buying the frog enough time to escape into the undergrowth. Ultimately, this visual warning works because it benefits both sides of the food chain. A bird avoids a deadly meal that would make it sick, and the frog escapes the encounter without a scratch. It's an evolutionary agreement written in bold, neon paint on the forest floor. By making themselves impossible to ignore, these tiny creatures found a way to survive in a world full of giants.